Hi friends, in this particular video I am giving you brief idea about what are the interrupts, okay, what happens when interrupt is occurred and how to create interrupt, okay. Let us see in detail all these things. So in the last video I explained how 8086 is interfacing with input as well as output ports, right? Now let us see here how we get interrupts, okay, and what happens when interrupt is occurred, right? Let us see. See here, microprocessor, in that we are concentrating 8086 interrupts. Let us see what is interrupt. Here, interrupt is a method of creating. I will take right. Okay. So interrupt is the method of creating a temporary halt during program execution and allows peripheral devices to access the microprocessor. So what is the meaning? So if interrupt is occurred, what happens? Processor execution will be temporarily halting. Okay, and external peripheral devices will take the processor. Okay, so for example, external device may have set of instructions. So external device wants to execute these instructions with the help of processor. In that case, what happens? It will it will create interrupt request signal to processor. So then the processor will halt the current execution. It will execute the instructions that comes under external device. Okay. Like that, interrupt is one method for creating temporary halt during program execution and allows peripherals to access the microprocessor. Okay, so in that case, there is one important device called it as ISR. It is called it as interrupt service routine. So the microprocessor responds to that interrupt with the help of ISR, interrupt service routine. Okay, which is a short program to instruct the microprocessor on how to handle the interrupt. So ISR is a one short program, and with the help of ISR, microprocessor understood that how to handle that particular interrupt. So ISR is a interrupt service routine, and it will give you a brief idea about in which way the corresponding interrupt is handled. Okay, that information is conveyed to processor. Right. So generally there are different types of interrupts are present. So interrupts are mainly classified into two types here: hardware interrupts, software interrupts. So hardware interrupts are further classified into maskable and non-maskable. Like that, we have many types of interrupts we can create. Okay, with 8086. Right. Let us see what are those. Okay, how we can get software interrupts and what are the various hardware interrupts. If you observe the pin diagram of 8086, so in that there are three pins. One is called it as NMI. Okay, other is called it as INTR, and other is called it as INTA bar 3. So these three related to external interrupt pins. Okay. So now there are some more in the program itself. We can create some interrupts. Those interrupts are called it as software interrupts. Like that, with the help of pins, we can select interrupts. Those are called as hardware interrupts, and with the help of program, we can create interrupts, and those interrupts are called as software interrupts. So in this video, we'll see in detail what are the various hardware interrupts and what are the various software interrupts. Okay, let us see. See here. Now coming to this one, coming to hardware interrupts. Hardware interrupt is caused by a peripheral device by sending a signal through a specified pin to the microprocessor. So hardware interrupt means if you take any external peripheral, so external peripheral may requesting the processor with the help of hardware pins. Okay, like in just now I explained, right? So three pins are there. So two are receiving pins for the processor and one is sending pin. So for example, two external peripherals can send the request to a processor with the help of hardware pins. Like INTR is the one, NMI is another. These two call it as a hardware input pins to the processor. Okay, then processor is ready to will send acknowledgement. Like that, some are hardware pins are there. See, hardware interrupt is caused by a peripheral device by sending a signal through a specified pins to the microprocessor. The 8086 has two hardware interrupt pins here. Two hardware interrupt pins are there. One is NMI and other is INTR. Because of these two, at a time two external peripheral devices can send the interrupt request to processor because of these two. If processor is ready, it will send acknowledgement to any one of the peripherals via INTA signal. Okay, two are the interrupt requesting and one is the interrupt acknowledgement. So see here in these two also NMI and INTR. NMI is nothing but non-maskable interrupt. So NMI is a non-maskable interrupt and INTR is a maskable interrupt having low priority. So in these two, which interrupt is having highest priority? NMI is having highest priority, whereas INTR, nothing but interrupt request, is having low priority. For example, two masters are requesting the processor for accessing the microprocessor for executing the instructions through NMI and INTR. So which peripheral sending interrupt request via NMI, it is having high priority. So which peripheral sending interrupt request to processor via INTR, it is having least priority. So first processor will execute NMI related peripheral instructions, later the INTR related peripheral instructions. Okay. One more interrupt pin is associated is called as INTA, called as interrupt acknowledgement. Let us see detailedly what is the role of NMI, what happens when NMI is occurred. Okay. So let us see in detail. Remember here it is a single non-maskable interrupt pin. Okay. Non-maskable interrupt pin having highest priority than the INTR, and it is a which type of interrupt? Type 2 interrupt. Okay, so in 8086 it can support 256 types of interrupts. So type 0, type 1, type 2, like that up to type 255 interrupts are present. So in the software interrupts we'll see all those types. NMI comes under which type? Type 2 interrupt. Okay, type 2 interrupt, this is important. So let's see when this interrupt is activated. So whenever NMI is activated, then what happens? Okay, we'll see here. This is a common most of the interrupts. So if you go for any interrupt, if any interrupt is activated, what happens? Which operations are performed? Mostly all are same. Only thing is IP is loaded with address. This address is changing. How to calculate this address? This address is generally depends on the type number into 4, because every interrupt requires total 4 locations. Every interrupt requires 4 locations. Okay. So if it is type 2 interrupt, then 2 into 4 locations, total 8 locations are required. Like the type 2 means 2 into 4. Like that we can find out locations easily. Okay, anyway we'll see. Okay, all these points are common, only this address is changing. Let us see first one. When this interrupt is activated, then what happens? Here first completes the current instruction that is in the progress. For example, if a NMI is occurred, what happens? Microprocessor executing some set of instructions. For example, microprocessor is at one instruction execution, one address in that instruction is executing. So it will complete the current instruction execution. So which instruction is executing, it will complete. Okay, it won't execute next instruction, it will complete current execution only. Then second, pushes the flag register values onto the stack. So flag register, what are the values that are present in the flag register? Those values are pushed to stack memory. That is another point. Similarly, pushes the code segment value and IP instruction pointer return addresses to the stack. So CS means code segment and IP is instruction pointer. Their return addresses are pushed to stack. So flag register values are pushed to stack. CS and IP return addresses also pushed to stack. Third is IP is now loaded from the content. So IP takes the data from which location? Which location it is? Type 2. Remember, type into 4 is the location. From that location it will take. So what is type number now? Type number is 2 multiply with 4, because each interrupt requires 4 locations. So type number into 4. So type number is for this case 2. So that's why 2 into 4 is 8. So what is the address now? 4 zeros 8H, because the 20-bit address. Left side 4 zeros 8H is the address. From that address IP takes the content. And then CS is loaded from the content of the next word. Next word. After this, what is the next word? Next 2 bytes nothing but word. So 8 after that, what is the next 2 locations? A. So from that 0000A, CS register loads the data, takes the data. Okay, CS is now loaded to 40CH, whereas IP is loaded to 408H. And one more is interrupt flag and trap flag. Both are reset to 0. So whenever NMI is occurred, interrupt flag is reset to 0 and trap flag also reset to 0. Okay. Let us see other one, INTR. So let us see what is INTR. What happens when INTR is occurred. So just now we mentioned INTR is one type of maskable interrupt, because the microprocessor will be interrupted only if interrupts are enabled during the set of interrupt flag. Okay, so here the point is interrupt request pin or previous NMI. So both are both pins are used to accepting the interrupt only when the interrupt flag is set. So see, the microprocessor can recognize the interrupts only when interrupt flag is set. See here, interrupt flag instruction must be set. So then only microprocessor can recognize the external interrupts. Okay, for activating this INTR, see here interrupt flag must be activated. Then other is the INTR interrupt is activated by an IO port. So this INTR may be activated with the help of external IO port also. With the help of IO port also we can activate this one. We can make either 1 or 0. So 1 activating, 0 means inactivating, like that. See, if in that case also remember, this is activating, NMI is assume activating, non-maskable interrupt is also activating. Then what happens? Processor won't execute INTR instructions first. It will execute the instructions that comes under the NMI related peripheral instructions only. Later, they will execute INTR instructions. Here, if the interrupt is enabled and NMI is disabled, then only microprocessor first completes the current execution and sends 0 to INTA bar pin twice. So INTA bar is 0, then only it will activate. So INTA bar is now 0 and that information is given to external peripheral. Then external peripheral understood that, oh, processor is ready to execute my instructions. Okay, like that it can understand. Okay? So here also let us see these instructions are taken care by the microprocessor. Whenever INTR is occurred, what happens? Here also processor will complete the current instruction. Second, INTA pin must be activating and the corresponding peripheral device receiving ready signal. With the help of INTA bar activating means it indicates that processor is ready to execute the instruction that comes under peripheral. That information also it will give you. Other is same flag register value, CS value, and similarly IP address. All are pushed to which one? Stack memory. Okay, then other IP value is loaded to which one? Here type number into 4. For example, INTR comes under, for example, type 6. 6 into 4 is the address. Okay. Similarly, CS is loaded to the next address. So here, for example, address is something like X, then added to 2 here, then we get CS address. Then here also interrupt flag and trap flag all are reset to 0. So remember here also flag register, CS return address and IP return addresses are pushed to stack. And IP is loaded with the address type number into 4. 4 indicates number of locations are required for each interrupt. X indicates type number. Type. Okay, interrupt type. Okay, INTR is a one interrupt. Okay, it is not specifically. So it comes under type 0 to type 255. In that one interrupt is INTR. So with that number we get. Okay, similarly here also interrupt flag and trap flag both are reset to 0. Okay, these two comes under hardware interrupts. So let us see other one. There are some software interrupts here. There are some software interrupts. Let us see what are those software interrupts. See here some instructions are inserted at the desired position into the program to create interrupts. See here we are creating some instructions within the program and those instructions related to interrupt. Then those interrupts are called as software interrupts. So within the program we are creating some interrupts. Then those interrupts are called as software interrupts. Okay, these interrupts instructions can be used to test the working of various interrupt handlers. Okay, with the help of these instructions we are checking. Okay, whether the current instructions are executed properly or not. Many operations we are checking. Let us see. First, one is in general for every software interrupts there is a INT. What is INT? Interrupt instruction with type number. So here we have many types. INT 0, INT 1, like that. INT overflow, like that. Type number is essential. So all software interrupts must be INT with the type number. Interrupt instruction with the type number. See here, it's a 2-byte instruction. INT is a 2-byte instruction. First byte provides the opcode and the second byte provides the interrupt type number. So generally INT is a 2-byte. First byte provides the opcode of the particular instruction and second byte provides the interrupt type number. Okay, so there are 256 interrupt types under this group. So interrupt instruction comes under total 256 interrupts are there. So those are called as type 0 to type 255. Type 0 may have one name, type 1 may have other name, like that. We have different types of interrupts are present. Let us see if in order to execute any of the software interrupts, so these points are common. What is first one here also? Flag register value is pushed to stack. CS value and IP value return addresses are pushed to stack. Same points. If either hardware or software, these points are common. IP is loaded from the content of the word location. This is also same. Type number into 4. For example, it is type 0. Then address is 0 into 4 is all zeros. If it is type 1, then type 1 into 4. What is the address now? 4 zeros, 4 HH. If it is type 2, 2 into 4, nothing but 4 zeros, 8. If it is type 3, 3 into 4, nothing but 12. 12 means C. 4 zeros, C. Like that. Where the type is changing from type 0 to type 255, that type into 4 is the address for selection of IP. CS is selecting next 2 more addresses after this. Okay. Here also interrupt flag and trap flag all are reset to 0. Okay. Now let us see briefly some of the software interrupts. Okay. For all the interrupts type 0, type 255, there are some names. Let us see few. First one is type 0. What is the name here? We are calling. Name is divide by 0 interrupt. So here whenever if any quotient is dividing, okay, so if it is divided by 0, if any number is dividing with 0, what happens? We get result, okay, having a highest value. Okay, nothing but indirectly it is infinity. Then in that case we get which type of interrupt? We are calling as a type 0. Okay, so when the quotient from the division instruction is too large to fit in the results register, 8086 will automatically execute type 0 interrupt. Okay. Okay, if result is quite large, nothing but infinite type result, then automatically 8086 will execute which instruction? Type 0. It's a type 0 instruction, name is divide by 0. Next other is a single step interrupt. Single step interrupt, also call it as a type 1 interrupt. Single step means the type 1 interrupt is the single step interrupt. Okay, in flag list I mentioned trap flag. Trap flag, whenever it is 1, then process will enter into single step mode. So in order to make that mode, then the interrupt comes under type 1. Okay, type 1. So the single step interrupt related to trap flag, it comes under type 1. Then type 2 is nothing but non-maskable interrupt, nothing but in hardware also we observed. So non-maskable interrupt comes under type 2. So here NMI comes under this family, non-maskable interrupt comes under type 2. Okay, this interrupt cannot be displayed by any software instruction. So non-maskable interrupt is activating only with the help of hardware, not with the help of software. Okay, but it comes under software family only, but we are not executing with the help of software instruction. Hardware only we are checking. Then other is breakpoint interrupt. Here, for most of the assembly language programs, we are ended with interrupt 3, that is type 3. Okay, interrupt 3 nothing but type 3. So breakpoint interrupt. So whenever if this interrupt is occurred, what happens? Automatically processor will execute the stop the execution. Okay, that's called as a type 3 interrupt. Breakpoint is here. The type 3 interrupt is used to implement the breakpoint functioning in the system, is stop the execution. Next, type 4 is overflow interrupt. Okay, so when overflow is occurred, whenever overflow flag is activating, then overflow is occurred. At that time, overflow flag interrupt is activating. Okay, if you perform any signed arithmetic operations, okay, overflow is occurred. So now like that, for 5 only here we mentioned type 0, type 4. Like that, we have 256 types are there. Preferably this 5 we are using, like the type 5, type 6, like that. Last is type 255. So like that, how many types are there? Type 0 to type 255. So each interrupt, this is very important point, each interrupt type requires how many locations? 4 locations, because of two 16-bit registers, because each interrupt may have two 16-bit related registers. That's why each 16-bit means 2 locations, like the 2 means 4 locations. So each interrupt type requires how many locations? 4 locations. Now 4 into how many interrupts are there? Total 0 to 250 means 255 means 256. So 4 into 256. 4 is the number of memory locations are required. Like that we have 256. What is total now? 2 square into 2 power 8. 4 means 2 square. 256 means 2 power 8. Total is 2 power 10. 2 power 10 means what is starting at? So now 10 zeros, 10 ones. 10 zeros. What is equivalent value? 000H. 10 ones. What is equivalent value? 3FFH. So starting address for any interrupt is 30H, and what is the ending address for interrupt? 3FFH. So in the interrupt vector table, we can observe same tables, the same addresses in that table. Then let us see first in type 3. Already few are already discussed in the general case. One is type 0 is nothing but divide by 0 interrupt, general one. Interrupt trap flag related one is type 1. Non-maskable interrupt already we observed, NMI. So what is now new type 3? Well, let us see type 3 here. Type 3 is a breakpoint interrupt. So whenever if this interrupt is occurred, what happens? Processor will execute processor will stop the execution. Okay, it indicates the end of the program. That is a type 3 interrupt. So whenever type 3 interrupt is occurred, what happens? Processor will take the, if it is interrupt 3, what is the corresponding opcode? Generally CCH. CCH is the opcode of that particular interrupt 3. Okay. Now, for example, if this interrupt is occurred, what happens here? If this interrupt is occurred, what happens? First, here also flag register is pushed to stack. CS value and IP return addresses are pushed to stack. Same, these 2 points are common for all the interrupts. Then other IP is loaded from the content of the word location. 3 into 4. Why 3? Because it's a type 3. Interrupt 3 is a type 3. That's why type 3 is 3 into how many locations are required for each interrupt? 4. 4 into 3, 12. 12 means next C. C is the address for this IP. CS is next 2 locations address. Nothing but C after DE. So 0000EH is the CS address. Here also interrupt flag and trap flag both are reset. Coming to type 4, it's a interrupt overflow instruction. So for this, if we execute INT nothing but interrupt overflow, so the corresponding opcode is, okay, in the opcode sheet we can see interrupt 0 corresponding opcode is CEH, whereas here CEH is the opcode. And whenever if any overflow flag is set to 1, then we can say that interrupt overflow instruction is executing. Okay, here also let us see type 4. Then what is the address? 4 into 4, 16. 16 means next it is a 10H. Okay, we can observe here. See, if this instruction is includes the steps. Here also flag register is pushed to stack. CS return address and IP return address are pushed to stack. IP is now loaded from the which address? Type 4 into 4, 16. Okay, decimal is 16, but in hexa it is 16 is equivalent to 10H. 10H is the address. CS is loaded with the next word location, nothing but 10 added to 2, nothing but 3 zeros 12H is the CS address. Here also interrupt flag and trap flag all are reset to 0. Now let us see other one, interrupt table. Okay, interrupt vector table. Okay, this is very important. Let us see what is your observation in the interrupt vector table. Here also how many interrupts are present, type 0 to type 255. Total 256 interrupts are present. So, and for every interrupt, okay, we are observing 16-bit representation, and for every type requires 4 locations. For example, so what is the starting address? 4 locations, and how many interrupts are there? 256. Then what is the starting address? In the last before slide I mentioned. So 30H is the starting address and 3FFH is the ending address, because 256 into 4. So 4 means 2 square, 256 means 2 power 8, nothing but 2 power 10. Okay, 10 means 10 zeros, what is equivalent hexa? 30H. 10 ones, what is equivalent hexa? 3FFH. So starting address of interrupt table is 3 zeros, ending is 3FFH. So type 0 starts from 30, end up to 000003 because of 4 locations. Next, where type 1 starts? Next 4, nothing but 004 to 007. Type 2 starts from 008 to 00B. Then type 3 starts from 00C to 00CDEF, 00F, like that. Where last in type end 3FF. Okay, like that we can analyze the interrupt vector table. So each type requires 4 memory locations and starts from 30, end up to 3FF. Okay, in that how many locations are, how many types are present? 256 types are present. Okay, all 256 types are present. Okay, like that we can analyze how interrupts are present. Okay, how interrupts are present and how interrupts are handled by processor, and what are the various hardware interrupts and what are the various software interrupts. Okay. For all the interrupts, remember, if any interrupt is activating, only thing is the interrupt flag must be enabled, then only processor can recognize the interrupts. Okay, so and one more important point is whenever interrupt is occurred, what happens? The flag register value pushed to stack, CS value and IP value return addresses are pushed to stack, and IP takes the address, IP takes the content from the address, type into 4, type into number of locations 4, that is the address. And CS will take the next 2 more locations, next 2 locations of IP address. Okay, and these points are common. And we have mainly software interrupts are of 256 types, type 0 to type 255. Like that we can analyze interrupts. Okay. Right. So thank you for watching this video. I hope you understand the operation of interrupts and the types of interrupts and all. Okay. If you really like, please kindly share my video to your friends.